Great. So the recording has been started. All right. So before we start our usual discussion, do you have any questions for me? All right. Do you have any questions for me before we start? No questions? All right. So we were discussing up these three questions, and today we are going to discuss the fourth question. In this unusual democracy where everyone is not equal, the vote count is a function of the worth of the voter. Though everyone is voting for each other, and so in this democracy, everyone is voting for each other, and the vote count is a function of worth of the voter. What does it mean? The vote of the rich person matters more than the vote of a poor person. Okay. Now, you're given a list of people with their value of the vote, and you're also given another list describing who voted for who. So, what do we want is at the end of day, what is the vote count of everyone? All right? All right. So, the all right. So the way to solve this involves two phases. One, where we combine and bring the worth of the voter and the so we bring all the people who voted for a particular person or voted by a particular person together. All right. So you have got list 1 and list 2. List 1 says who voted for who, and list 2 shows and list 2 shows the worth of individual. So what we need to do is in our usual case, what could we have done is one, we have joined list 1 and list 2 on the basis of the person or the voter. So list 1 dot voter equals to list 2 dot person. That's what we have done. We could have done in the case if our data was in relational database and we were supposed to use the database. All right. First, we would have joined list 1 and list 2, and then we could have given the group by, we could have done group by on the voter. And based on the group by, so yeah, so basically we could have simply done a group by and we could have computed, sorry, we could have, yeah, once we had joined list 1 and list 2 based on the voter, as in who voted for who, okay, and then if we group by the votee in the result, then we would get, and then sum up the worth, then we would get the output. Okay, so that's what we're going to do. That's what we are going to do with the help of MapReduce. Okay. Again, if we have to do this using SQL way, what are we going to do is we take list one and list two, join them based on the list one dot voter equals to list two dot person, and then And then in the next query, what we will do is we will do a group by based on the votee. Okay, based on the votee and sum up the worth. Correct? So after we join list 1 and list 2 based on the voter, the worth of the total worth rewarded because of this voting comes together with the votee, and therefore after grouping, the summation would lead to each votee's total worth. Correct? All right, let's have a look at it. All right, if you want, I can write an SQL query giving you an idea about how would it look. Let's say there is list 1 and list 2, correct? So we could have done select star from list 1, join list 2, or we can say L1, L2 on L1 dot voter is equal to L2 dot person, correct? And here we could have said L1 dot voter, or we don't need voter, and all we need is worth. So we got votee and the worth in this, and we say select this into a new table called L3. Okay, so we are creating another table called L3. Now, after we have created another table called L3, we could have simply said select L select person, or you can say select votee, and sum of L3 dot worth from L3 and group by L3 dot votee. Okay, or we could have just said votee. All right, so L1 has voter and votee, and L2 has person and worth. Good. So is this query clear to everyone? So you can see that we have to go with two phases. Good, very good, Biswa. Biswa is saying we could have done a left join and get the result in one select statement. Um, so when you do the left join here, you will have to do a group by here itself. Basically, you combine these two statements together. Okay. And please note that we are joining on voter and we are grouping votee. So if you try to, you're still figuring out how would you combine these two. The way you could combine these two is by putting a brackets around here and then say as L3, it's like set based operation, and then you could put a group by over here, correct? All right. So this is how I would do using SQL. So what we noticed here is first we bring all the records together from both the tables based on a particular key, correct? Similarly, by grouping, we bring all the records of a particular votee together by grouping on votee so that all the words contributed to votee come together. All right? All right. So let's take a look at the MapReduce using the uh, MapReduce for this kind of problem. First is that list 1 and list 2. If we put list 1 and list 2 in the same folder, if we put list 1 and list 2 in the same folder, then we can feed the whole folder to the MapReduce. All right. So that's one key insight. Second is we'll have to use two phases of MapReduce. Okay. And we will talk about how to chain multiple MapReduces afterwards. All right. So you have got list 1 and list 2. While on list 1 and list 2, both have similar format. The first one contains the voter and then tab and then votee. And similarly, second one contains voter and then tab and then the worth. So if you just put these list 1 and list 2 in a folder and then you run the map reduce, your map reduce will get the input as if it's a single file. All right. So if you don't do anything in the map, all you do is take the records and make the in case you detect the record is from list 1 or list 2, you just print it as such. Okay. And also please note that in case of MapReduce, you won't be able to distinguish whether the record is from list 1 or record is from list 2. Okay. Although the data is available to you in the parameters in the MapReduce. We'll try to see that. Okay. So we basically put these two files together in a folder, and then when our mapper, even though mapper doesn't do anything, all it does is in case of list 1, the key is this, value is this. In list 2, the key will be this and value will be this. Value will be worth. Okay. Now, what Hadoop will do as part of bringing all the keys together, it will group the data based on the key, and all the values will come together, which means the values will contain worth as well as the votee. And as you can see here, for A, for A, 5, comma B, comma C has come together. 5, comma B, comma C. 5 from this side and B and C from this side. Similarly, for B, 1, comma C has come together. For 1, comma C has come together, these two. And for C, 11 and F have come together. 11 and F have come together. All right. And then you do a reduce. Okay. So in the first phase itself, in your reduce logic, you do a key value preparation. If you can see here, we basically do a key value preparation here. Why? Because in case of reduce, you will get A and all of these values together. Now, as part of reduce, you start giving out key and the values further such that we clearly display that hey that so as part of reduce, what we could do is we basically take reward B and C 5 each, because what does it mean? It means, if you see clearly here, that A voted for B and C, and A's worth is 5. So because of this voting act, how much did B gain? B gained 5, C gained 5, while A did not gain anything. We'll talk about why are we putting this A0, because we want A0 in output. Okay, so because A voted to B and C and A's worth is 5, so in the reduced phase what we do is we print out B5, C5 and A0. Okay, second is in this one you can see we'll be printing C1, and in this case we'll be printing F11. All right, now in the next phase, this first column is the key and the second column is the value. All right, then Hadoop will bring all the values together, and then in the reduce phase we sum it up and we get the values. So this portion is a little tricky part. First what we did was we brought all the people who a person voted together along with the worth of the person. And then in the next phase, we rewarded the worth to each individual who has been voted. Okay, and and then we basically do a group by, the one which the group by like we did in third A question. All right, is it clear to everyone? No. Mahesh's question is, I'm confused as how you mapped the two files into one. I'll tell you why. All right, that's another question. All right, coming back to it again. All right, coming back to it again. So, first question from Mahesh is that I'm confused as to how you mapped two files into one. Okay, so if you remember, in our case of Hadoop MapReduce job, even in the streaming, we could provide either a file name or a folder name. If you provide a folder name, all the files in that folder will be treated as the input to the MapReduce and will be concatenated. Okay. So in the similar manner, if we take list 1 and list 2, put them in a folder, that will become the input to our MapReduce. All right. Now next question is, are you treating second value in the to list as string? All right. That's a good question. So answer is yes. So we'll be treating the second value as the string only while translating here from string, we will translate it into a number. Okay, we'll translate here, we'll parse it and we'll convert it from 5 is treated here as a string and we will treat it as number here. All right. Next is, can these be applicable to the scenario where both list 1 and list 2 have millions of record and spread across multiple machines? Yes. All right. Yes. The only situation where this this algorithm may not be of much help is the situation where one particular person is voting for millions of people. If A voted for millions of people, what would happen here is this list is going to be really, really big, and this reduce may not be able to handle that. All right. So if that list of people, the votees is too big, then If a person has voted for millions of users, then this strategy may not suffice. Otherwise, this strategy will be good enough. Those kind of strategies can be further streamlined by the way of uh, selecting the different set of key values. Okay. All right. Okay. Okay. So, so Mahesh, was I able to answer your question? Great. All right. There's a question from Biswa. Question is, what will be the sequence of concatenation of files, although it's not important in this case? All right. So that's not, I'm not very sure the sequence of the concatenation. Okay. So generally it's alphabetic. I'm not sure about this. Now, question from Yashwant is, will you always get the number in the first occurrence? No. You will have to scan through the values. All right, brilliant question. So, Yashwant's question is this MR chaining? Yes. Basically, we will talk about how we can combine two map reduces back to back. Like as you can see that there are two map reduce phases. The input of one is the output of another. So the second one needs to be executed as soon as the first one finishes. Now to control that, you have something called map reduce chaining. We will talk about it, the various techniques to do the map reduce chaining. All right, good. So so that way, is the problem clear to everyone now? Is everybody on the same page? Should we move on? All right, all right, good. Now, Mahesh's point is that it is clear for now. I hope to learn to execute how to execute or implement later. Good. Yeah, all right. Biswa's question is: we are not reporting the the votees with the zero votes. We should do that. Okay, we can actually do it very simply by here while combining we could not have skipped the ones with the zero values. Okay, here if you notice up to here we have mention of zero, but here we have not mentioned. Ideally we should. Thank you for that. Yeah, good. All right. All right, Biswa, we can report. Good, good. So everybody is on the same page. All right. So most of the time we start believing that for every kind of problem can be solved with MapReduce, but that's not right. We should not be and we cannot use MapReduce in certain cases. For example, first, if you think that the job can be and will be easily handled with a single machine or single node, then don't get into MapReduce. Okay? Just for the heck of it, just for the sake of using MapReduce, don't use that. Alright? Because MapReduce will be slower in the cases where it is fairly faster on a single node. It'll be slower on multiple node. Why? Because because there is a boot up time. MapReduce takes time to create blocks and transfer the logic to network, communicate with communicate with all the nodes, finding which one is free and all that. So that takes time. Therefore, if something can be happily done using a single node, do it using a single node or do it using your traditional strategies. Okay? Don't get into MapReduce if you don't need. Second is because it's not so in software engineering what happens is most of the time people are doing stuff doing various kinds of the programming or various kinds of development just because it's industry wide good practice. Okay, so that's not the case with MapReduce. It's not something like even if you don't need it you are supposed to do it. It's not like uh, you have to use MapReduce, no questions asked. Like when we say you have to use JUnit no matter what. Okay, that's not the case with MapReduce. You have to always judge whether to use MapReduce or not. Okay, this is a very important aspect because uh, or I would say that use whatever is faster, whether MapReduce or your local system. Okay. Next is the computation depends on previously computed values. You cannot use MapReduce in the cases where the next step in the computation is dependent on previous step. Why? Because the next step can only be executed once previous step has finished. Therefore, it can only be done at a single place on a single computer. It cannot be done parallelly or on multiple computers. Therefore, the problems like Fibonacci series should not be solved or cannot be solved using MapReduce. It won't be effective. It wouldn't make any sense to distribute that kind of logic, or it will be not possible to distribute this kind of logic. Okay. Third is real-time response. In the situations where you are expecting real-time results, as in the latency of zero point 0.5 seconds, okay, in those cases you cannot use MapReduce because MapReduce has been designed to be very fault tolerant. It has been designed in a way that slower is okay, but it should give results. It should be able to handle huge data. It should give results. It may be, it is okay to be slower. So that has been the psychology while designing MapReduce. Okay. Therefore, if you need real-time response, don't put that task into into the MapReduce. Fourth is that when your program needs a global state, if your program always need to communicate, imagine There are many map reduces, and each map reduce talks to a central database before processing a record or during processing a record. This every node which is executing map task is communicating to the central state, as in maybe a database or some other other agency or agent, to which every map is talking before doing anything. Now you can see that in such cases the overall throughput of the system will be badly impacted and will be a function of how fast is your call to the central agency, central database. Okay. So in such scenarios, again, the system has become kind of linear because all these machines are waiting for central global state. Correct? Therefore, therefore, it doesn't make sense to use MapReduce in such scenarios. Okay. All right. So Fibonacci series, for example, Yashwant is asking for more details on this. So what does it mean by Fibonacci series? Let me explain to you. So Fibonacci series, let's say first number is 1. Second number is the summation of first one and before that. Let's say first two numbers in Fibonacci series are 1 and 1. Now, the third number will be the summation of the first two, which means 2. And fourth number is summation of 2 and 1, that means 3. And 2 plus 3 gives 5. 5 plus 3 gives 8. 8 plus 3 gives 13 and 21 and so on. Okay? All right? All right? So this is Fibonacci series. Summation of the last two gives the result to the next one. Now, as you can see in this clearly, that the next step, you cannot go to next step unless you have done the computation of previous two. Therefore, such Fibonacci series generation cannot be parallelized. It has to be sequential. Make sense, Yashwant? Great. All right. So these are the situations where you should not be using MapReduce. All right. Now, testing is very important with MapReduce. Okay. In case of Java, we'll discuss it again. But in case of streaming, you will have to learn how to test these kind of scenarios. Okay. So first, test on very small data. Okay, and this data you should generally prefer a random sample over first 10 lines or last 10 lines kind of sample. Okay, rather than taking the sample from one side, you generally take a random sample. Next is, you should test your mapper and reducer separately. Okay, and then you should test the overall. So whatever test cases you write, you always do that test of mapper and reducer separately. The streaming job can be tested in a very simple manner. Okay, you can see that. You can basically test it offline without talking to Hadoop MapReduce. Like for example, I've written cat input file, pipe the data to my mapper, then sort and then execute the reducer script. And whatever is the result, you save it in a file. So basically, this command summarizes what each mapper reducer do and Hadoop does in case of the Hadoop streaming. So you can see clearly that mapper converts input key into something which can be sorted, and then reducer basically takes the output of the sort and does something in case of streaming. So you can do it easily. So when I was learning for the first time, I basically learned with Hadoop streaming, and I found this aspect really powerful. I was able to I was able to test my MapReduce job without having to bother the cluster. I was able to test everything offline without having to install Hadoop on my local machine. I was able to test everything, all my scripts, by using this kind of strategy. Next is using MR unit. MR unit is another something for Java developers. Will show you a couple of examples of MR unit. Okay. Now another challenge that you will face in case of MapReduce is that mostly you will be dealing with big data, and sometimes you will be dealing with big data for predictions. Okay, let's say you are building a system to recommend movie ratings to people. Okay, you are recommending that these are the movie ratings. Now how do you test the correctness of such system? Okay, so you generally break down the data into two parts. You learn from one part and compare from the second part. Okay, this is very important. So you split the two data into two parts. Okay, and generate the prediction, or you feed your MapReduce logic with the first part of data. Let MapReduce give the your MapReduce, or let's say you're using a tool called Mahat. Let the prediction come and then compare the result against the second part of the data. Basically, it's like asking an astrologer about the past in order to validate whether the astrologer is able to predict anything or not. All right. So this is a very important way of testing any hypothesis or any prediction. Okay. So Bishwa's question is, can you repeat the dependency on global state? Let's say your code depends on a global state. Let's say it's a central database, and every time any map get executed, it's talking to that central database all the time. In that case, the central database will be the bottleneck. Okay, and therefore your map reduce will be inefficient. Okay, Yashwant, do you need more details on comparing predictions, testing the predictions? All right. So basically, let's say there is a huge database of who liked which movie and how much. Okay. So A liked A1 movie this much, and so on. You have been given this huge database of users about their rating. Now, what you are building is you're building the movie recommendations for these users based on this data. Okay, so what should we do? What should we do in this case? How will we test? Okay, so what you will do is for testing is first you break down this data. This data contains user, movie, and the rating. Three columns: user, movie, and the rating. Correct? And there is one more fourth column, which is timestamp. On what date this user has rated a particular movie. Okay, so what you do is you break this data into two parts. Let's say 50-50. Okay, so you break down this data into two parts, or maybe 80-20. So preferably take it 80-20. So you break down into 80-20 in the sense based on 80% of data, you will create the recommendation. So based on this 80% data, we found out A may like this movie and B may like this movie. Now, take the remaining 20% of data, compare with the results and check whether he actually liked those movie or not. And that gives a very of clear picture of your quality of recommendation. Okay, Mamta, did it make sense to you now? Midley's question is very good. On what basis you split the split it in two parts? Generally, we split the data chronologically. Okay, that you watched these movies earlier. Now you in future you are watching some other movie, and based on the behavior of other users, we are predicting that you will like this movie. So, did you actually like this movie? Okay, that's what we are comparing against. So based on first 80% data, it, and this slicing generally happens based on chronology. Okay, so based on first 80% data, we generated the recommendations and compare those recommendations with the 20% and check whether it actually happened or not. Biswa's point is the 80% sample should have been dated earlier to the 20% data. Yes, that's correct. All right. As an exercise, you should check Netflix challenge. Okay. So Netflix challenge was an interesting challenge, and okay, that actually became very, very popular. Okay. It was a 1 million reward for the algorithm, which would get the correct recommendations. Okay. All right. So check how did they ensure whose algorithm is performing better. They had split the data into two halves. They gave you the first half, and then you have to then compare your results with the second half, and that's how they computed the predictions. All right. Okay. So from For these all problems which we have discussed so far, you should prepare your MapReduce in your favorite language and execute that as in the execute that using Hadoop streaming. Okay. Also create a project on GitHub. Okay. GitHub is a good way to to start with your developer profile. As of today, your GitHub profile matters a lot in hiring. Okay. So create a repository here. Okay. Create a repository. So what is Git? Git is basically source code management system, and GitHub is a hosted source code management system. And the public repositories do not cost anything, while private repositories are only paid. Okay, so you can try it out. It is going to be useful. All right. All right. So you can take a look at GitHub, create a repository, share with us. Okay, and mention no big data in the readme.md file. All right. So next question to all of you is, you're given a huge content from a very large text archive. Formulate the next word recommendation. Okay, what does it mean? So have you must be using mobile these days for typing. So when you type a word, the keyboard of the mobile generally gives you the recommendation of a word to be typed next. Correct? So those kind of recommendations are to be generated and to be pre-prepared. Okay, so that is the objective. Let's just say top three recommendations rather than top five. Okay, and how do you prepare such kind of recommendation? You go through the full text archive. Prepare the statistics, as in which word appears after a particular word how many times. And out of all such words who appear after a particular word in the normal conversation of the people, what you do is you compute the frequency, as in which word appears most and which word appears least. And based on that, you have to pick up only top three for each word in the dictionary. All right. So that's the exercise for all of you. Is the problem clear? Is the assignment clear? So problem one is code all these for five problems, whatever we have discussed so far. Code them in your own preferred language, right? So far you have written only the steps and the strategies part. Okay. Yes, we will show it now in Java. Okay. This is more about streaming. Now we will show it in Java. All right. Good. So now let's move on to the Java part. All right, everybody, is the both assignments clear to you? Yashwant's question is, MR chaining is somewhat we need to know. Not really. You will notice this, that even if you manually execute the two commands, it's completely okay. All right? Even if you manually execute the command, it is completely okay. All right? Good, good. Let's move on to the. All right. All right, a quick recap of whatever we have discussed so far. All right, here we go. All right, quick questions, everybody. The data generated by mapper is given to reducer and then it is sorted and shuffled. Yes or no? Mahesh ji, again. Mahesh ji, could you go through the question again? The data generated by the mapper is given to the reducer and then it is sorted and shuffled. Yes or no? Is it first sorted or is it directly given to the reducer? That's right. That's right. Yes, it is. Answer is no, because the output of the mapper is first sorted and shuffled, as in if there are multiple reducers, the data is shuffled, and then the reducers are called. That's correct. Good. Very good answers. Brilliant. Now, next question to everyone. The mapper can only generate a single key value pair for an input value. Recollect how many how many key value pairs were generated per line in case of word count. So, mapper can only generate a single key value pair for input value. Is that true or false? All right. So, okay, let me help you answering this question. So, in a single line, for a single line, in case of our word count problem, how many keys were there? Single key or multiple keys were generated by our mapper. What was the key and what was the value? Each word was the key and the value was kind of null, right? So, did we only generate one word per line as the key or did we generate multiple words per line? That's correct, Mahesh. We can split input into multiple key values. That's right. That's right, Mahesh Arora. Good. Good. Uh, uh, so I did not get, Mahesh. Are you changing your answer from true to false or false to true? We created one key. Our input was one single line for each map task, right? So we converted that each line into multiple key values, correct? Each map function converted a single input line into multiple words, isn't it? I'm talking about Mahesh Arora. All right. So, are you agreeing with this? So, answer is false. Mapper can generate as many key values as it wants. There is no restriction on number of key values. Mapper can generate 100 keys for a single input. All right. All right, everybody, okay with this? All right. Next question to all of you, that a mapper always have to generate at least a key value pair. Is it true or is it wrong? Imagine that in our big.txt file, the input word count which we did, what if an input line was blank? Do we have to generate a key value for each line, or can we skip generating the key values? Correct or wrong? A mapper always have to generate at least a key value pair. Is that correct or wrong? The answer is wrong, because mapper does not have to generate even a single key value pair. There is no such condition on mapper. Whether it's a choice of mapper, that whether it wants to generate a word, or generate a key value, or generate one key value, or generate 100 key value, it's a choice of your code, your mapper. Okay, it's a very important question, because the definition of mapper, as you will see when we discuss Spark in detail, the Apache Spark, there the default mapper means one input, one output. Okay, but in case of Hadoop, that's a big difference. Our mapper can choose not to generate a key value pair, can choose to generate 100 key values, or can choose to generate only a single key value. So it's a choice of our key value, our mapper. That's correct, Mahesh ji. Yes. All right. We can have logic to generate key values only for values which we are interested. It's our call. Okay. Now, so a quick question to all. By default, there is only one reducer in case of streaming job. Yes or no? By default, there is only one reducer in case of streaming job. Yes, that's right. By default, there is only one reducer. Okay, one reducer, but it can be split by specifying a command line option called mapred.reduce.task. Okay, we could say minus capital D and then mapred.reduce.task equals 10. In case of Java MapReduce, the number of reducers are decided dynamically. Okay, in case of Java MapReduce. Midley's question is, can the number of reducers be zero? Yes, that's correct. Your point is correct. The number of reducers can be zero. All right. In case there is no reducer, the output of mappers will directly go to the file system. And we can turn off explicitly the shuffling and sorting phase. We can say that, hey, we don't want any shuffling and sorting phase. That makes the whole process really faster. Alright, quick question. What is the role of job tracker? A. Executing MapReduce logic. B. Delegating the MapReduce logic to task tracker. Correct. So everybody is correct this time on this one. Yes, it's B. Perfect. Brilliant. Thank you, Medili. All right. Next question to everyone is the map logic is executed preferably on the nodes that have required data. Yes or no? Good. Good going so far. Good Mahesh ji, Yashwant, Mamta, Abhay, Biswa, Medili. Good. Keep going. Yeah. All right. Good. So on this, everybody is agreeing. MapReduce is executed preferably on the nodes that have required data. Brilliant. All right. Here is the twist to the sentence. The map logic, not MapReduce. The map logic is always executed on the nodes that have the required data. Always is the keyword here. Good, Yashwant. Yashwant, I'll repeat your answer after some time. All right. Good. Yashwant's answer is not always, even though it's desirable. That's correct. That's correct. Yes. Even though it's preferable to execute the map task near to the data, but in case the node on which the data is located, all the three nodes on which three replicas of data are existing, if those nodes are busy, that does not mean our map task will fail. It only means that our map task will be executed on some fourth node. Alright, brilliant. Where does Hadoop store the result of reduces? Anyone? It is in HDFS or it is in local file system. The output of our word count was stored in local machine, or was it in the HDFS? The final output of your word count process, where was it? Was it in local system or was it in the HDFS? How did we see where the outcome of our MapReduce word count problem? Yes, it is stored in HDFS. Brilliant. Now, next question to all of you is, it is in, okay, so the final outcome of MapReduce process is always in HDFS. Keep this in mind. The final outcome of HDFS process, the whole MapReduce process is in HDFS. Okay, even if there are zero reducers or there is no shuffling, the outcome is always in the HDFS. All right. Now, next question to you is, now while MapReduce task gets executed, as we showed you earlier, there are intermediary stages. Mapper generates the key value pairs. The key value pairs are are sorted, and then after sorting, they are fed to the reduce process. Right now, now where does Hadoop stores this temporary or intermediary data, in HDFS or in the local file system of individual machines? Correct. That's right. So first it would First, it would try to put it in the memory, and then it goes into the local file system. Why it's kept in the memory? Because because it becomes faster. Okay. So first it puts it in memory, and then memory keeps on purging out to the disk. All right. Now, this is a question which I don't expect you to answer, but if you are answering, I don't expect you to answer correctly. Okay? So, question is, the whole of the HDFS block on a node is fed to the mapper. Anybody? So as we talked about earlier, the file is split into file is split into blocks, and then while we run the map reduce, our mapper will be executed near to the block. Okay, preferably on the same node as block. So question to you is, this whole block is fed to the mapper, or only part of it is fed to the mapper? Anybody? Okay. All right. Abhay says block may be splitted across different mappers. Viswa says depends on the block size. Midley says there is no need to feed all of the blocks. There is no need to feed all. So I'm saying whole block, not all of the blocks, whole block. Okay, Maheshji says that whole as it is only 124 MB and generally memory is in GB. Okay. Okay. Yashwant says whole file will be read by the mapper. Biswa says the mapper has to scan the entire block. Okay. Yashwant says whole block will be fed. Alright. This question is difficult to answer, honestly, because this is something which I want to discuss now after this Java discussion we'll have. Okay. So the whole block cannot be fed to the mapper, right? Why? Because recollect that the blocks are ruthless slices of the file. I'm using the word ruthless because HDFS does not care whether the boundary is in the middle of line, or boundary is middle of sentence, or boundary is middle of word. Okay, so HDFS slices the file ruthlessly into exact size of 128 MB. Okay, except for the last one, the remainder one. Remainder one is generally smaller than the normal blocks. Okay, so you can see that it's not logical while we are processing data. It's not logical that it will not make any sense. Imagine while doing the word count, half of the word is in one block and half of the word is in the next block. Now, doing such kind of word count does not make sense. Same word is being counted twice, correct? So, it's not possible, it's not logically possible to feed the whole block to a single task. Reason is different at different times you will have different kind of requirements. Sometimes you may want to process the data line by line. Sometimes you may want to process the data paragraph by paragraph, or sometimes you may want to process the data exactly 50 records per time. Okay, so in all these kind of different kind of scenarios, you will have to break the blocks into something called input record. Like the way big.txt in case of our word count was broken down by map into line by line, right? Not block by block. Block does not make any sense while doing the computation. Okay, because block is only for storage. It's not a logical entity. Yes, one point is if there is a single mapper on that machine, then the entire will be read. Yes, that's correct. That is a very, very good point. I think I should make a note of this one. Yes, if there is a single block, then the entire block will be fed to your program. All right. Mahesh is saying, is the real-time data, say from web logs, fed real-time into HDFS or like a batch job? Okay, so in this case, although we'll discuss it again, we will generally use tool like Scoop, and data does is fed to the system in a real-time manner. Okay, but it's not processed in the real time. Sorry, not it's Flume. You are right. It's a Scoop. It's a not Scoop. It's Flume. All right, that's right, Yashwant. Thank you. All right. So whether it's records or unstructured data, we generally use Flume for real-time pushing the data from all the servers into HDFS. Okay, batch-wise processes for copying the data to HDFS does not help us much. Okay, Scoop is a batch-wise process. Yeah, yeah. Yes, we'll be covering Flume and we'll showing you an example of exactly this scenario. How we will be feeding data continuously to Flume and it will keep on uploading continuously to HDFS. We will show you that example. Alright, Mahesh? No worries. Alright, so no, the input is split into input splits and the part of which is transferred to other mappers. Okay, we will see that later. Alright, this is a good question. Let me just read it out for everybody. In case of word count problem, if the file is split into two blocks, a word nowhere in such a file is now and here falls in the second. We will run mapper separately on both now and here extra count. Yes. So these kind of problems are avoided by transferring nowhere to one of the nodes. Very good point, Biswa. So this is something which is a part of input record formation. Before the map process kicks in, records are created out of the raw blocks of data. And then once we have raw blocks of data, we have once we have input record which are created from raw blocks of data, the counts are taken into account. Okay, because to create records out of raw data, there will be transfers on the boundary conditions. All right. So Yaswant's question is, so if we are transferring data to other mappers, then won't it result in data traffic? Wasn't it mentioned transferring code is smaller and faster? That's correct, Yashwant. But if you think about it, we are only transferring minuscule data over the network. All right? And the process is happening parallelly across multiple nodes. Okay? Therefore, the overall result will not look impacted. Mahesh's question is, who is defining the records from raw data? Brilliant questions. We will talk about it after the Java part. All right? Because this is what I wanted you to think about, and you guys are on the same right direction. His question is, who is defining the records from raw data? This is where the input format comes into play. Okay. Yes, Biswa, that's right. There's a bit of processing before the input start, map reduce start. All right, billion. So everybody is in the right direction. Okay. So is everybody with me? All right. Mahesh, you wanted the clarity on which part? Good, good. I would like to park it for some time because he wanted to understand. His question was, who is defining records from raw data? Okay, we'll park it for some time and we'll come back to it later. All right, all right. So there is one library as part of map process. Okay, there's a library. There's a library which will convert the input raw data into records. And you can write such kind of library for yourself as well. All right, good, good. All right, so, all right. Now, one question which everybody asks is then why Java? First, why do we need to learn MapReduce in Java? Those who are not clear, who are more interested in Java part, they are not very fluent with Java, they can quickly go through my slides and then videos if they want to learn Java part. Okay, a better way to learn from self-paced courses is you just quickly go through slides. If you find something which is not clear, you go to the video to that section and then locate it. Okay. All right. So there are you go to Yashwant, you just go to my courses and there you will see Java. Okay, a Java course for you. If it's not there, just let me know. We will enable Java course for you. Java course is generally available for everyone. Okay. All right. So why do we need to do MapReduce in Java? Because even though we were able to do it without Java. All right. One is Java has got primary support with Hadoop. Okay. Hadoop is written in Java, so it's easier to provide a library in the same language. And since it is got the primary support with Hadoop, you can modify the behavior to a very large extent. All right. So to run or to write MapReduce in Java, all you need to do is first install Eclipse, create a Java project, and add all these libraries. Change JDK to 7.0. change the Java compiler settings to 1.6, and then you go with next step. Okay, all right. A easier way would be that you go to my courses here, and here you will see the sample project. You download the sample project, and after extracting, you will see a folder, and that folder you can import. After you have installed Eclipse, so you can download Eclipse from the Eclipse's website. Whichever Eclipse is there, you can install that one. That's okay completely. All right. So here you can see you can download the project, and then you can click on import, and there you can say existing project into workspace, browse to the folder where you have downloaded this project, the project which we were mentioning here. You download this sample project from here, unzip it, and then from here you go import and click on browse and select the folder which you have downloaded. Okay, and then say finish, and everything will appear. In case it's not working, okay, also I have created a small video of how to create a project. Okay, just go through this small video, that will also help. And then I have created a 2 minutes video on how to debug. Okay, all right. So once you have the project here, I'll just go through the examples. All right, all right, here. Okay, so install Eclipse, create a Java project, add these libraries, or instead of step number 2 and 3, you just import the project which is available there. That will give you a good starting point. Okay, but note that if you import the project, make sure that you import the libraries as well. Okay, I think I should, yeah. All right. Just try to follow this how to create project. That'll give you a very clear picture. All right. Now let's go through an example of word count using Java MapReduce. Okay. All right. And also change the JDK to 7.0. How do you change? Let's say this is the project which we are talking about. Okay. Or we are talking about, let's say, this project. Okay, trg2. So if you go into this project, right click properties will take you here, and you can go to Java build path, and here you can see that I'm using a JRE 1.7. Okay, if you are having JRE 8 or something like that, you can select any other environment by clicking here. Okay, so generally, you can basically let JRE be the way it is. This is how it is. In the Java compiler part, keep this Java compliance level as low as possible. Okay, preferably to 1.6. Okay, preferably to 1.6. All right. Why? Why do we want to see keep compliance level to lower? Okay. All right. Because in the production, in the production there could be different. All right, let's take a break. We'll get back after the break. All right. All right, can we start now? Is everybody back? All right, great. Mahesh ji, we will discuss this in a minute. All right. He has a question related to the splitting. All right, we will discuss it, and that is going to be. It's good that it is confusing to you. That means that you have thought about it. All right. Okay, and all right. So once you have created a fresh project, you can create a mapper. Okay, the first step is to create your mapper logic. Now from here to here you can see, or you can have a look at. So let's take this project. So once you have imported, you will create the first file as the stub mapper. You can see here stub mapper. What does it do, this stub mapper? So the actual code, the one which you are supposed to write, is this. Rest is just the skeleton. Okay, because in Java you have to define everything as a class. So your mapper is a class that extends the base class called mapper. We are extending a super class called mapper, and everything. If you want to make a MapReduce program, you will have to write mapper by extending mapper, and this will basically inherit all the logic which was there inside this mapper class. Okay. Now this mapper class, we are saying we want to concrete this mapper class. This mapper class is very generic. It's for all kinds of data types. Here we are saying stub mapper is a mapper where input key is object, input value is a text, and output key is text, and output value is integer, right? Because we are going to give word count here. So while extending the base class, we specify that this class is an instance of our base class called mapper with these data types. Okay, the way when we define something like integer x, we say that x is an integer. Similarly, we are saying we are extending a base class. Okay, we are extending a base class saying stub mapper is a mapper with these data types as the input key and the values. These are the data types of input key and values. Whatever you have here, you will have to write the same data type in the mappers key. Now let's have a look at this main function called map. So after you have created a stub mapper, after you have created this class called stub mapper, you will have to, all right, is the audio not clear to everyone? Biswa, are you able to hear me? Looks like he's not able to hear. All right. Now, okay, so this is clear to everyone. Now, we define the class. Inside this class, we are supposed to define the rest of the body. Okay, let me just delete this portion. Okay, now we can say public void. Okay, now, all right, or we could write things like override, override. All right, never mind. So yeah. So here, this is the class first you define. Then you define your map method. And what does map method? Let me delete inside of this body. Yeah. So map method is basically something you define, which basically overriding the map method of mapper. Okay. And here inside this map method is you are going to write the code, right? Here inside this body of this map method, you are provided with key, value, and the context. Okay, what does it mean? We are given the input key and input value. Now, as opposed to what we have talked earlier, that we'll get an input line, right? In case of mapper, in case of Java, you get two things: input key and input value. Okay, in case of default behavior of MapReduce in Java, the key is the byte count. Okay, the value is each line. Value is the each line in the input text, and the key is the byte count on which this line is starting. Which character is it in this file? Instead of saying which line is it, we say which character it is. Okay. So we'll get the input line and the number of character on which this line is starting. All right, and then we get this. We'll have, okay. So here inside this we are going to write our code. What are we trying to do? Value dot toString. We got the input line using value dot toString. Then we replaced everything which is non-alphanumeric with space. Okay, we replaced non-alphanumerics with space, and then we split the line on spaces, whether tab or space or multiple times. So we split the line on spaces, and once we have the list of words, then we iterate over the words and then generate the output. Okay, now this is how we generate the key value pair. This is how we generate the key value pair. The context object is something which takes the key value pair from us. We write context.write and the key and comma value. Okay, this context object is something which gathers key and the values from all the mappers which are running in the system. Okay, so context is the bucket into which you put your output. All right, sounds good to you? No? So this is your mapper class, and please define a package in your project, and also note that whatever package you define, there will be a folder name in with the same name. Similarly, whatever class you define here will have the same file name. Okay, so we created a stub mapper. And what does mapper do? Given the input byte count and the line, it generates, it writes to the context the key and the value. And what does value means? Value means here we are putting 1 as the value. Okay, 1 as the value. Please note that instead of using the standard Java string or standard Java integer, there are these wrappers called int writable and text. Okay, now how do they matter to us, or what was the need of these kind of new data types? So how do people realize that the data types provided by Java are difficult to convert it into string, as in convert it into bytes? So they came up with their own data types so that the serialization could be easier. Okay, So every time we say new text, we are creating an object and we are wrapping our actual text. Okay, it's like this statement is like gifting somebody something after putting a wrapper or a gift box. Okay, so we are giving, so word is being wrapped into text, it will become text after this. Similarly, one, you can see one, this is a numeric one, is being wrapped into int writable. Abhay's question is, can we create a sample input file that this will consume? Yes. Okay. Okay. So let me just try to show you. All right. Let's log in into Hue. Okay. I'll exit from admin account. I'll go into my account. All right. Now that is the login, and here is my password. All right. So the file which we are going to process as part of this is under file browser. Okay. So you go to slash and data. Now here you can see that under data there is word count folder. It'll be map reduce. Where is MR? Here. Under that there is word count and then there is input. Okay, so this is the text file which we will try to process using our file. Okay, you can create your own folder easily, it's not difficult. Okay, you can just create or upload file into HDFS and you can start processing that. Okay, so this is the input text file. We're going to do the word count on this input text file. So Yashwant's question is, how are we assuming that there is a tab between each word? We are not. We are saying either space or tab. Maheshji's question is, how many mapper object will be instantiated on each data node? Okay, is it dependent on the line or the blocks? So generally, out of each of the blocks, something called input split is created. Okay, it's a very important question. I think I should take it now instead of later. How many mapper objects will be initiated on each data node? Okay, so this class you see stub mapper. Question is, how many instances of this one will get instantiated on each node? Okay, the answer is it is a function of input split. And input split is a function of blocks. Generally, input split is prepared by removing those boundary condition, like so Biswa was giving an example of no and where, right? So removing those boundary conditions, input split is prepared out of each block. Now, based on if one node is having 20 input splits, there will be 20 instances of our mapper class. Okay. All right. So here we are. So this is our input text file and this is our mapper. Now, once you have created a mapper, now you will have to create something called a reducer. Okay, again, here you extend the base class called reducer by specifying what kind of data type are you looking for. Here we are saying that reducer will get input key and values, text and int writable, and reducer will write to the output text and the long writable. Okay, so this is basically the data types of key and the values which we mention while extending the base class. Now whatever you specify here, you will get the same thing here in the reduce function. Also, whatever data type you have in the output, those are the data types of the context. All right. So here we are wrapping our sum into long writable instead of int writable. And what exactly are we doing? We are saying long sum equals to 0. Iterate over the values. These are the input values which are given. Also notice that it's a list of values, not a single value. So for all the values of this key are brought together and are being fed in the form of values to our reduce function. Okay, so here what we're saying is for each of the values for a particular key, we got a list of values which need to be summed up. So we are iterating over the values, increasing sum by the integer, and then we are writing to the output. Okay, all right. So this is our reduce function. All right. I will take your questions. All right, I'll take your question now. One of the questions. Question is, can the key be separated by space? That is, can the key be a compound word? Of course, it can be. Okay, if you're using Hadoop, this one, the key can be anything. Whether it's a compound word, binary data, it could be anything. All right, it could be anything. Alright, so that was our reducer. We talked about mapper. Now, we have defined mapper and reducer. Who will stitch them? Who will tell Hadoop that, hey, this is the mapper, this is the reducer? For that, we have to create something called a driver. Driver has got the main entry point called main method, and under which first we create a configuration, we get the job instance, the job task scheduler basically, and then we to the map reduce job we say that this is my mapper, this is the name of the class, my stub mapper dot class. Okay, and this is my reducer. So we are handing over the name of our mapper, name of our reducer, to the job. Along with that, we are saying that the map's output key is text, map output value is int writable. So here we are defining the data type externally as well. Okay. Also, please note that there is something called input format class, and this is very important. This class dictates what to do with the input data, how to create the input records out of the raw input data or HDFS blocks. Okay, so this input format class is used for translating the raw data into some meaningful data. All right. And then in the last, what we have done here as part of the driver, what are we trying to do? We are trying to say Job, we are setting the input path parameter of job. Similarly, we are setting the output path parameter of the job. And what is it that we are setting it to? We are setting the zeroth argument and first argument. So zeroth argument is the input path, and while first argument is the output path. And in case we do not provide the argument, it will give us an error saying this. Okay, so you can see that it has got three classes. First, stub mapper. Also, please, so we have got stub mapper, stub reducer, and stub driver. The name of stub mapper, stub reducer, and stub driver could be anything, whatever you want. Okay, this is not mandatory that you have to call your classes and mapper, stub mapper, or stub reducer. All right. So this was the driver. So we got three classes. All we have to do is now, what we need to do is we need to export it. Okay, we have to export it to a jar file. Okay, so we are saying it should go in the, we are saying mrtrg2 dot jar. Okay, it's done. Now how do we take this file which we have created locally to the server? Okay, this is two-step process. We will first upload it to HDFS and then we'll take it to the local directory. Okay, we will first upload it to HDFS. And how do we upload it to HDFS? Using Hue. I'll click on home. Okay, we are saying upload files. Okay, we are going to go to the download folders. Okay, all right, we are uploading the file which we have just created. Why it says no route to the host? Just a second. All right, it has been uploaded into my MR TR2. Now let's open. So we have uploaded our file into HDFS, but for running Hadoop jar or any MapReduce process, this jar file has to be local. Okay, so we'll go to our web console. Mahesh's question is, what is the variable my? It's the package name. It's like a folder. Okay, let me increase the font. Okay, here we go. All right, let's copy this Hadoop FS, copy to local. Okay, now data. Under data, you have, not data. Let's first copy the jar file. Okay, jar file is mrtrg2.jar. Okay, so it must have copied it here. You can see that mrtrg2. Now we can say Hadoop jar, and it says provide the main class as argument. Now what is our main class? The main class is the driver which we are talking about, and driver name is my stub driver. Okay, it says, now you can see that it says stub driver input and output folder. Where is it coming from? Where is it coming from? From this line. It's coming from this line. That means our program is being executed. Okay, the logic is coming till here. Okay, now this is very important. This is very important. All right, so good. So we are, so what all we did, first we created a project, then we created stub mapper, then we created stub reducer, then we created stub driver, then we exported it into jar. Okay, exported into jar, then we copied the jar into hdfs, then we took from hdfs to the local folder, and then we executed hadoop jar and that file, and then it asked that please specify the class name, then we specified the class name, absolute class name of our driver, right? And then it's asking for input directory and output directory. Okay, so which folder do we want to process? We want to process slash data slash mr, what was that folder name, slash data slash mr slash word count and slash input. Note that we are providing the full folder. If there are 10 more files in the same folder, the output kind the those all 10 files will be taken into account. Now we are saying, let's say December 7 and mr out. Okay, so this is how we are running the MapReduce. What does it say? It says that it has started the processing, and it says, what does it say? Okay, so one of the node is giving problem. Reason is that we have shut down one of the nodes. Okay, and it says that this is the URL to track. It has finished the map part. It is starting the reduce part. You can see that. All right, here we go. So it's showing us the complete detail of the map reduce process. In the meantime, you can check the logs. What's exactly happening? Okay, so it says this log is this much. Okay, not this. We have to check the console. This. So it has started the process of MapReduce. Let's just wait a little bit and see if it gives us some results. Okay, Midli's question is, where are we defining the input and output location in the program? So we are not. We are just saying, here you can see, we are saying we are setting these two parameters to the job. We are saying add input path to the job, and this is the path. And what is this path? It says argument 0. So whatever argument we are providing to Hadoop jar is being passed to Hadoop driver, this is step driver, and then step driver is picking that and putting it into the input path. Similarly, for output path, we are setting the argument 1, which is the second argument, to step driver, and that's how it's being picked. All right, does it make sense to you, Midli? Okay, so I will be taking up your question. Okay, one is how many times the map function is being called for each mapper object. Is it based on the input? Yes. All right, so here we go. Why it's taking so much time? No, it has finished already. It says that one is successful. Yeah, it has already finished. Yeah. Now in the logs, you will see there are std error, std out, and syslog. So if your program is writing to a standard output std out, this is where your output will be. You can see d d d d d d. This is what was printed by ourselves. You can see we are saying system.out.println dddd. Okay, so this way you can debug your program. If you have written to the std error, you can see this error is something which we are writing. Make sense to you? So yes, these input files which we are talking about here, these input files are in HDFS. Okay, these input files are in HDFS. Okay, also when you start the process, every Hadoop job gives you a URL to track the progress. Every Hadoop job gives you a URL to track the progress. You just go to that URL, and then and then and then you can see exact details of what's going on. All right? Good. Does it make sense to you? For some reason, this thing is not exiting. All right? All right. Yes, one's question is if they are in HDFS, if the files are in HDFS, okay, they'll be distributed across the machine. So how can we specify the directory? So every file or the directory which we create in HDFS, it is available. So basically, if you look at the HDFS, it's basically very much like a file system. There is no difference between normal file system and the HDFS with respect to the logical view. All right. All right. As you can see, this is the folder file structure of the HDFS. All right. So we were able to successfully run our MapReduce program. All right. Now there is another part to it. What all we did just now? First, we exported the jar, then we copied the jar to the HDFS, then we copied to the local, and then we executed MapReduce, right? And then we checked whether the result was right or wrong. You cannot afford to do this in due course of development. Reason being, first, the process is very lengthy. You may not like to do it every time you make a slightest change in the code. Secondly, you cannot run this kind of thing in the actual cluster. What if your program has a bug and it takes up all the memory from the mapper and the reducer, or it unnecessarily keeps on troubling yarn again and again, even though it's giving an error? Now, so it's very important not to bother the main cluster, the production cluster. And that's why the testing comes into play. So this testing is done using MR unit. MR unit is a extension of JUnit, okay, for unit testing. So what you do is you create a class called stub test, create a setup method, and start testing. And in the setup method, you create the mock drivers and mapper, mock driver, and mock reducer. Okay, I'll show you this. So here you can see there is a stub test. Okay, there is a stub test. In this, we are creating a map driver, reduce driver, and map reduce driver. Okay, as I told you, to test mapper reducer separately from the whole process. Therefore, similarly, we are creating three instances of these three. And then, if you notice here, we are creating the instance of the driver and instance of the reducer. So we have created a stub mapper, we've created a stub reducer, and we fed this object to this driver. Okay, so this driver, similarly reduce driver and map reduce driver. So basically, we have told the testing framework that these are the classes which we want to run as mapper reducer, and this testing framework is going to run it. You can see that in case of test mapper, we have to the map driver we told that this is our input key, this is our input value. Now run the map driver, and whatever is the result we are comparing here. Okay, so what exactly did we do? We are trying to mock it so that it runs locally without having to take it to the server, right? And for that, we first thing we do is we create these drivers: map driver, reduce driver, and map reduce driver. Then we specify the table definition for each mapper reducer and map reduce together. Okay, and then we for testing we set the map driver some input data and some input value, and then we run the map reduce driver. Okay, this is what we do. Make sense to you? All right, all right. Let's try to run it. So to running it, you don't need a Hadoop installation. That is the reason why we need this kind of testing. So we can say run as JUnit test case. Okay. So it shows that this one has failed because we have written it to fail, while this one has succeeded. This one has succeeded. Okay, so you can test the MR unit code just like this. All right. All right, now with respect to the output class of our previous attempt, you could see the result here in hue. What was the name of the file? Anybody? User. Okay, you can see the result. All right. All right. Now there's a question from Yashwant. Question is, Java has so many frameworks. Which one we should know for this? Not any, except for JUnit. You don't need to know any other framework. Okay. Can you share the basically for this? There are a few things you need to know. One, classes and objects. Okay. Then the other part you need to know is the generics or templates we call it, and then JUnit. Okay. Can you share the skeleton of this whole MR program in Java, like what classes, what method need to program? Yes, you can just have a look at this thing. Now. Here, in case of we have inside here, if you go into session number 5, you will get two projects. One is in session number 4, not here. Yes, where is that project? Yeah. So yeah, there are two projects. One is very simple project, other is a complex project. Just have a look at it. Okay. All right, Mithili, is that what you're looking for? It's a complete project. You just import it to Eclipse. You will see all the classes and objects, and we'll give you the details. Now, question from Mahesh is: do you have a reference list of all data types used in Hadoop? I don't, but have a look at the Java docs. Okay, have a look at the Java docs. Okay. You can say Hadoop writable writable classes. Okay, writable classes. So you can see that the writable interface is being used by so many of them. Correct? You can see that because anything that has to be serialized, as in converted into the bytes from the objects, that has to implement a writable. Okay, you have tuple writable, and you have there'll be int writable somewhere. So you can see int writable. So these are the all writables. Okay, you can see float writable. Okay, there are so many writables. Long writable, text. All right, all right, good. Does it make sense to you? All right, now going ahead. So this was our MapReduce test case. Running MapReduce test case was very straightforward, and we could test things very quickly. Okay, we here if you see, for our MapReduce driver, we are saying that this is our input key value, as in we are putting some number as key and value as our input line. This is another key, this is another line, then we are running it. Okay, we are running it, and then we are asserting, we are checking whether the output size is greater or smaller. Okay, so every time we make a change in the code, all these test cases will be run. You should run these test cases and test whether it was successful or not. All right. So that was the test cases. Now we have already asked you this. Okay, we'll discuss this problem maybe tomorrow. Okay, for now, I want to discuss something important. All right, the input splits and rest. Okay, the problem which I gave today, we'll discuss it tomorrow, but let's discuss now the input splits. Okay, good, good. As we talked earlier, that the files are sliced into blocks ruthlessly. Why I call ruthlessly? Because it doesn't care whether the 128th MB byte is ending at in the middle of the word, in the middle of multi-byte character, in certain language like UTF-8, in the character format like UTF-8, um, single character might be multiple bytes. Okay, it might be made of multiple bytes. So in those cases, even the character will be cut into half. Okay, even a character would be cut into half, and half of the character is on the one block, and half of the character is on the other block. Now, for your program, if you are reading block just like that, it wouldn't make any sense. It wouldn't make any sense because it's not a logical representation of data. It's like binary data. It's like bitwise data. Okay, because the block boundaries are ruthless. And why are they kept ruthless in block boundary fixed? Why they're kept fixed is because we don't know at the time of storage how this file is going to be passed. Second, it keeps the system simpler and easier to tackle. Okay, because at the lower level like data management, at the file system level, we cannot afford to put so much of intelligence. All right, so out of the blocks we create or we provide MapReduce program to which will create input split, so that let's say you can see that the block boundary is lying in the fifth record. Imagine that your data is made up of records, and record could be lines the way we have tackled in our input text file. Imagine, or the input record could be as complex as the as let's say the binary data containing row by row if you are dealing with Excel sheets. So here you can see that there are 11 records. First block boundary is on fifth block. So part of the fifth block, the part of the fifth record is in the first block, and part of the fifth record is in the second block. Similarly, the ninth record in the input data or ninth line in your input text file is on the block boundary. I'm talking about the figure above. These two example are different. They are not same. So don't get confused. Okay. All right. Now you can see that the block boundary is lying in the middle of ninth line as well as. But while processing the data, we wanted complete lines. We did not want the lines to break. Okay. We did not want the lines to break into parts. Correct? And therefore, we need to prepare input splits out of this raw data. Okay, I hope the problem statement is clear. Yashwant's question is, can we give uh, dot as the input split? Yes. Mahesh's further question is, the block 1 and block 2 and block 3, there are three blocks, right? They could be on different nodes. Yes, they could be on different nodes. Okay, this is where, so converting this Physical block into input split is where the input data format comes into play. Okay, so in input split, Hadoop divides input into pieces called splits. One mapper instance per input split. Okay, one mapper instance. You remember our class stub mapper dot java? That instance, that class will be, that object will be created per input split. If your program has 100, your data has 100 input splits, then there will be 100 instances of that class. Okay, a split could contain multiple records, and map runs on each record of the split. Okay, so stub mapper will be instantiated once for each input split, and stub mapper dot map method will be called the dot map method. The map method was there in the our stub mapper, right? That map method will be called on each record. We cannot afford to create stub mapper for each record. Instead, stub mapper is created for the whole input split, and for each record inside input split, our stub mapper's map method is called again and again. All right. Now, Mahesh's question is, what is the criteria for input split? It depends on what we are looking for. Okay. The input split and the record definition comes from what is your requirement. We'll talk about it in a minute. Now, record, each input split is further divided into records. A map function is applied on each record. A record is a logical entity. You can take the analogy with databases records. Okay, and input format creates the record. It is the input format class that creates the input splits and the records. All right. Also, please note in the input split, since input split is created out of the block, SDFS block, if input split is not similar in the size as the block, what will happen is there'll be too much of transfer of the data. So based on the HDFS block, we input splits are created. How? The boundaries are shifted from one node to another. Boundaries, the records which are lying on the boundary, either they are moved to the left or the right, and we create the input split. All right. So a good input split size is going to be closer to the HDFS block size. All right. So how do we specify this criteria that, hey, I want to break down this file into line by line. In case of our word count problem, we did the counting of the words line by line. Each map method got a line as the input, right? The key was the byte count, while the value was each line. What if tomorrow you want to process the data, say uh, say how should I say, paragraph by paragraph, correct? Right now our data is split by single slash n, right? How do you define a line? A line is defined as something separated by slash n. A word is defined as line splitted by spaces, correct? Similarly, the whole text is, if it is split by slash n, then we get lines, right? So by default, when we do not specify any input format, our data is split into line by line. Tomorrow you might want to do it something else. For that, you will specify another input format class. Now you must be wondering, where is that? you can see here, if you go to the driver, step driver, you will be able to see, you will be able to see the input format class. You can see in the job definition, we are saying set input format class. Okay. Here we are saying key value text input format, or simply, this was just for example, we could say text input format. Okay. Makes sense to you? And we, all right. So this way we can specify how our blocks will be converted into the input splits. This text input format class is the one who is going to do the magic, converting our converting our blocks into splits. All right. So the text input format. So Mahesh's question is, does the Hadoop copy data from data node 2 to data node 1 if the input split is running mapper on the node? Yes, that's correct. So in the formation, in the process of formation of input split from the data from the HDFS block, there will be transfer of the data from one node to another. Okay, from one mapper to another, there will be transfer of the data, because this portion of fifth record will be transferred to the first block. Similarly, this portion of the data will be transferred to the first block. Okay, a second block, this portion, you see, this portion will be transferred, and that's how it will happen. All right. So the logic in each translation, if you think about translation, what's happening, we are converting the block into the input split. So what happens is the process starts parallelly on all three of these. This person, here, here, here. So it notices that it has not reached the boundary yet. It keeps on throwing the data to the previous node. Okay, and the moment the boundary is reached, then it starts creating the input split. Similarly, third one also, when it started notices that there is no boundary, so it starts throwing the data to the previous node, which it will take into consideration later, and it'll find out where is the boundary, and as soon as it meets the boundary, it starts creating input split. So all the three nodes parallelly are creating their input split. And how are they creating? They keep on searching for the boundary. They, as soon as they found the boundary, they start creating input split. Otherwise, they will keep throwing the data to the previous node. The previous node will keep the data unless keep the data and then join it to form the complete fifth record. So this portion of data here, this portion of data has been thrown from the second node to the first node. Similarly, from third node to the second node. All right. Midli's question is, in case of blocks, we have the size of 128 MB. Is there a boundary for input split? The answer is depends. It all depends on what kind of input split definition are you using. So, for example, we are talking about an input format called text input format. In case of text input format, the each split is made up of lines, and each line is separated from another line by slash n. Okay, so each record is a line, and input split is nothing but bunch of lines. Okay, and these lines are by default separated by slash n. In case you want to split the data by dot, you can very easily do that by setting this particular configuration as text input format dot record dot delimiter. you can say simply like this. You can set this variable in the configure like we have set here. Okay, text input format dot set input split size. You can also specify the size, and there was input split set. Okay, it's not allowing me to do that, but anyway, we can do things like job dot set, or there was one more thing. Yeah, I think it is done. You could say configuration dot set. Not like this. We'll say conf dot set. Yeah, we'll say like this. In case our data is separated, in case our data is separated by another delimiter, let's say we have our file which is where the lines are separated by, or records are separated by, say, semicolon, then we can define things like this. Okay, so we can define a delimiter in our text. Yashwant's question is, how do we define input file format in case we are coding in the Python? Yeah, so if you are talking about the Hadoop streaming. If you look at the Hadoop streaming command line detail documentation, it says to you that you can specify that from the command line arguments. Okay, you can define command line argument. Now, there's a very good question from Yashwant. How do you specify paragraph as the input format? In case of defining the paragraph, you have to put double slash n slash n is the double new lines as the input separator. Okay, sounds good to you? Brilliant. All right. Now that was the simplest of all, which was text input format. Where now Mahesh's question is, how is the data transferred? So that data is transferred. I'll show you the example. I'll show you the example of input splitter. So there is a full mechanism provided by Hadoop, okay, where this translation of input split preparation happens. That preparation provides an API and conversation between mapper and mapper for facilitating all of this. So it keeps an in-memory buffer for this kind of work. Mahesh's further question is very good questions actually. I must appreciate this. If the Hadoop creates 5 input splits from a block on a data node, it runs 5 mappers on that node. Yes. Okay. Basically, five. It will instantiate your stub mapper, your mapper class 5 times, and map method will be called once per record. Good. All right. Now the next kind of input format, which will help you limit the lines which need to be processed per mapper, is 10,000. You can sorry, you can specify how many maximum number of lines you want to be processed by one mapper. Okay, these are very very useful when you are doing things like writing a crawler. You have say 10,000 URL to crawl, and you want to limit one mapper to crawl only 100 files. Okay, oh sorry, 100 URLs. In that case, you will say that total number of lines per mapper should be 100. Okay, so in those cases, if you want to split, you want to limit number of lines, you could use n line input format. Okay, then there is something called fixed length input format. Okay, this is good for if you're processing the data which is of the fixed length format. Okay, sometimes your records are of fixed length, specifically when you're dealing with the database files, the records are of fixed length. You can specify that here, so it will not have any separator. Instead, the length will be used to separate one record from another. All right, there's one question from Yashwant. Whenever the delimiter is specified, is the mapper executed for every split based on the delimiter? Yes. So based on the delimiter, the input splits are created and mapper is called on input split. All right. Midhili's question is, will it run 5 mappers on a node or a mapper will run 5 times? Midhili's question is, will it run 5 mappers on a node or it will or a mapper will run 5 times? No, it'll run 5 different mapper instances. Basically, your step mapper class will be instantiated 5 times. If you have got 5 input splits, if you have got 5 input splits, your input splits again is equivalent of the data block. Input splits contain record. You can think of an input split as, say, uh, input split equivalent of say 500 lines. Okay, one input split could be similar to 500 lines, and for each input split, your instance of mapper is created, and for each row, the map method of your instance is going to get executed. Okay, your instance of the stub mapper contains a method called map method. So your instance will be created, stub mapper's instance will be created once for each input split, but the map method of your instance will be applied or will be called that many times. The function call called map will happen that many times. Okay, it's like loading a program and calling a program. Okay, that's a difference. So stub mapper will be instantiated once for each input split, and stub mapper's map method will be called per record inside input split. Okay, my AC's question is, say I have an input split of 10,000 lines and one mapper is running. Okay, does it call 10k maps async or sync? Those are called in a synchronous manner. Yes. Okay, so I'll show you. Yeah, so if you go to stub mapper, so when there is this class called stub mapper, right? Hadoop will create many instances of this stub mapper, one one instance per input split. Okay, and then on that object it will happen. Okay, on that each one, or I can show you this. How should I say? I'll try to write a pseudocode. I think that will be better. For each input split in for each input split of a file, for each input split of a file. Okay, instance equals to input mapper, instance equal to new stub mapper. This is what Hadoop is going to do internally, and this will happen uh, parallelly. Okay, this will happen parallelly for each input split of a file parallelly. Instance equal to stub mapper instance. Now for each record of input split, it's going to call instance dot map method, and we are going to feed this. Okay, this is what is going to happen. Does it make sense to you now? For each input split of a file, this will happen parallelly. Instance equals to is new stub mapper. The instance of the stub mapper is being created so that we don't need to create this instance again and again for each record. Okay, then for each record of input split, we say instance.map and record. Is it clear to everyone now? No? Did I confuse you? Yes, one's question is, when you specify a delimiter, record is created based on the delimiter. That's right. Records are separated, or records are created based on that. Good? Alright, Mamta's question is, output files stored in local file system from the mapper is same as the number of mappers on the node. Output file stored in the local file system from the mapper is same as the number of mappers on that. Perfect. Perfect. I'll try to put your question in a little bit different fashion. Okay, that will make more sense. I think that will make more sense. Okay. All right. So there is this good question. Yes, the default delimiter in case of input text format is /n. Okay, now there is a question from Mamta. Question is, output file is stored in local file system from mapper is same as number of mappers on that node. Each mapper will have output file in local system. Yes, intermediately it will be that way. But imagine that there are no reducers for your map reduce. Let's take an example that we don't have a reducer. So what would happen in those cases? The output of the mapper will be saved. Output of the mapper will be saved directly into HDFS. Then you can actually test it out. You can actually test it out that if you have 50 input splits, there'll be 50 output files of the mapper. Okay, you can try it out. If we specify, let's say let's take this case, this n line input format. So for our map reduce program, let's say we are using n line input format, and what we are saying lines, number of lines per map. Okay, number of lines per map are going to be 10. Okay, so we are saying per input split will contain only 10 lines. So for 100 lines, how many input splits would be there? 10, right? In this case, there will be 10 input splits. So if we do not have a reducer phase, you will see in the output folder, there are 10 files created by the input split, created by the map process. Okay. Biswa's question is, in case of word count problem, the record is a single word. No. Sorry. Yes. Yes. In case of word count problem, the input record is a line. Input record is a single line. Okay. So question is, in case of word count problem, the record is a no. Record is a single line. Input split is bunch of lines. Okay. All right. Did it make sense, Biswa? Does it fall into place? No. Biswa's question is, in such case, we have to specify three delimiters. What kind of three delimiters? So we only are specifying one delimiter, that is how to separate one record from another. Okay. And based on that, input split is also being created. Okay. There is no separator between one input split and another input split. It is same as the same separator as what is there between two records. So input data is split into records, and bunch of records make the input split. Now Yashwant's question is, do we do image processing etc in MapR? Yes, we do. Okay. In those cases, we use a different input format. In those cases, we use different input formats for image kinds, such that hues files, hues image files will be splitted into into proper sections of the data which are meaningful. Okay. All right. So we have fixed line input format where every record has got the fixed size. Okay. Next is the key value text input format. In this case, Biswa, we will have two kind of separator. One is the separator which separates the record from another record, and the other separator which separates key from the value. By default, the separator is equals. So key value format, each record is considered made up of key and the values. The files are broken into records, and each record and by the way of slash n. Okay, so every line is broken down into key value pairs, and so on. Okay, if there is no equal sign, or there is, it will be considered that there is no value. If there are more than one equal sign, then the second equal signs will be part of the value. Okay. Now there is an interesting file input format. What if your data is binary data? Okay, so generally Hadoop guys came up with a nice file format called sequence file format, and correspondingly there is a sequence file input format. Okay, so they defined a file format called sequence file format. What does sequence file format do? It is great for storing lot of binary data such as movie, music, medical records, and even zip file. So a sequence file contains a huge header, and then there is a body. Okay, so sequence file format is very great for using with Hadoop, and that is why there are many converters. So you convert the other kind of files into a sequence file, like for example zip file format, tar, everything we convert that into sequence file format. Okay, also a lot of times we have very small files. Imagine managing the profile pictures of a billion users for your website. You will have billions of images. Now you can't store them in a normal file system, so you'll have to move to HDFS. But if you move those kind of files to HDFS, they'll consume a lot of space in name node, because for each small file there'll be a metadata, a lot of metadata. Therefore, and there'll be only a single block. So it'll consume a lot of name node metadata space. Had it been a single file, then also the metadata size is almost similar. And even if they are a billion file, the the metadata size will be billion times bigger, right? Therefore, what people do in cases for storing smaller files, what they do is they create a zip file, a compressed archive file out of the so many small files, and then translate it into sequence file input format. Okay, the quality of sequence file input format is that the processing of data can be parallel. Unlike unlike zip file, you remember zip file, unless you have all the parts available on a single computer, you cannot decompress such file, right? You remember those days when we have floppies, when we were copying the file part by part, and if either of the part is not available, we were not able to decompress that. Sequence file format has got couple of compressions with which you can actually parallelize the whole activity. All right, so that is the sequence file format. Also, there are a few more notes I want to uh, come to you. One is that while using the compression, you can use ggzip splittable or ljado. These are the basic compressions supported by HDFS. And generally, if you are storing lot of logs, for example, because in organization logs are generated in a huge manner, so you can store them with a compression called ljado. And this compression has got this quality that it is splittable, in the sense that each HDFS block is compressed. And while converting this compressed block into input split, you can do it independently. You don't have to bring all the blocks to single place and then decompress it and then we prepare input split. No, with using this kind of formats, you can simply start using the input split conversion, the text one, anyone. They all support this algedo compression inherently, and it'll be parallel. You don't have to bring all the data at one place, decompress, and then no, you don't have to do that. You can compress the file in a manner that this is splittable. Okay, second is inside any map reduce, you can simply call this file system API use to directly talk to HDFS. So far what we talked is that we will provide our data as input. What if our program wants to read directly the HDFS file? Our MapReduce program inside, it tries to read the data from HDFS. You can do that by using HDFS API. This is how, so file system API of MapReduce provides you a way to read data directly using this kind of format. All right, so we will talk about more details about input displays tomorrow again. Okay, we'll show you an example of this. Okay, can you come again? Okay, so basically what I'm trying to say is, so far our input is our program did not interact directly with HDFS. Our program can also interact directly with HDFS using file system API. Okay, all right, so that's pretty much for today. We will talk about input splits and few more things tomorrow. All right, and then we will continue our discussion on pig. All right. Yes, one's question is, but in that case, won't it become sequential? Yes, it would become sequential partly. All right. Good points. Yes, Mahesh, when reading from file system. Good. So his question is from Mahesh is that when we try to read from the file system, like using file system API, okay, does it read all the blocks or the block on the data? No, it reads all the blocks. It talks to HDFS as an external agency saying, ki, hey, give me this file. And then HDFS will give, okay, here are all the blocks, go and get it. And this file system API will do all the job of retrieving data for you for your MapReduce program. Okay? Yes. So these are a few exceptional cases where you may want to read this file system API at period of times, okay? Not inside your map method, but maybe inside the constructor of your mapper. Constructor of your mapper as in when your mapper gets constructed, maybe at that point of time, you may want to call it once, right? You may want to read some file. All right. But that's just one requirement. If you take a look at Hadoop dist CP, we will cover Hadoop dist CP. If somebody can remind me, I'll have to note it here. Okay. So if you look at the command called Hadoop dist CP, it makes call to file system, remote file system for copying the file from one HDFS to another HDFS. We'll talk about it again tomorrow. All right. See you tomorrow. Have a great day. Bye bye. All right. Thank you. Sure. We will share these notes, Mahesh. They'll be available in the course page itself. I'll have to check if they are available or not. All right. How do you exit from here? Bye bye. Have a good day.